Okay, I think we can get started. So welcome everyone on this afternoon session for Asset Lifecycle Management and Optimization Strategies. And we'll start our first presentation on FDI meets plant device integration needs. Ludwig will be presenting. I think it's a group effort, so go ahead.
Thank you. So, my name is Ludwig Winkel. I'm affiliated with Siemens, located in Germany. And this presentation, as he mentioned, is a co-production from Jonas Birch and Terry Blevins from Emerson Process. Terry is here with us. Jonas far away in Singapore. Stephen will also take part of this presentation and take over roundabout half of this presentation if I'm tired and probably speak not fast enough so that we get the presentation in time. Based on I'm not a native speaker, bring me probably in some trouble on some slides with some words, and with that Stephen will take over after a while and going in details. So I'm involved in this FDI technology, what we are presenting here, also on the standardization side, that means IEC side, also an effort within ISA, the ISA 104, which I'm also involved as vice chair. Terry is the chair of this group where we are dealing with this technology in ISA, but also within IEC, I'm involved in this topic as well. So Stephen will give some more information about himself later on, starting with what we are talking about, the topics covered. 6 main topics around about this device integration technology, the field device integration technology. That means the investment protection, robustness, ease of system administration, ease of device use, interoperability, migration, but also starting with the technology itself and ending with a conclusion. So what we are talking about when I say integration technology. A couple of days or on Christmas time, you will get a couple of parcels under the Christmas tree, and you will find there a temperature transmitter, a pressure transmitter, a DCS system, a level meter, and a couple of cables, or even on a wireless system, some additional manuals. So what you don't want to do is first to read a couple of 100 pages of your manual before you can handle those devices to establish your own home automation, that you get the rain level and the temperature. If it is below 0 degrees, it doesn't make sense to start your sprinkler system for your garden, and to combine all these devices in a intended way so that your garden will get wet at the right time, but not too wet. So that's integration technology that we try to avoid, that you have to read a couple of thousand pages for installing device types around a communication system to fulfill the application. That was also done before, if you heard about EDDL or FDT. What I'm trying now to convey here is a little bit more than just to zip the EDD and the FDT, to combine those just in a zip file. It's more. What we are doing here is that you can get rid of reading all the big bucket of manuals, but of course you have to read the safety instructions. But you get rid of all the details of which parameter is inside, what you have to set about, what's also limits, how to you have to use to establish a communication between the devices, and those should be done by the elements which are given in a field device integration, it combines the EDDL also with the elements of the FDT2 so that a single device package can use on any system. So that's not trivial if I'm saying on any system. That's essential. Because later on you will hear about operating systems, Windows and all this. You will hear that. There are also end-user demands behind. The NAMUR, for example, a chemical pharmaceutical industry association, provided a requirement list with about 35 requirements in the NE 105. What should a integration technology do? And that was especially also fulfilled by the EDDL. Why we have to deal with now FDI with more? And what are the benefits? So even FDT technology covered most of those requirements. But what we learned is take best of both technologies together. And that will provide the big benefit, and that is what I'm talking about now. Not get rid of EDDL, not get rid of the FDT, but combining both to a single technology. That you do not have the burden to handle a lot of different set of files, so that it is an integrated technology for the integration technology. Behind this, what I said before, it is more than just a zipping of two files. The technology itself is a little bit complex, but what you see as the surface is simple. It's a device package and the common host components. You do not have to handle more than that. But of course, behind, similar to your iPhone, if you have this intuitive surface, it's simple. You can handle it easily. Even my grandson, 7, can handle that. But behind there is a complex implementation that is hidden for you, so that you just have to see device package and see common host component. The device package. What you see here again, the EDDL. Here we are, yes, we didn't substitute something, but we used the ED, and also the FDT components can be used in this arena. So that means the file created by the device manufacturer for each device is the FDI device package. So out of your box of your temperature transmitter, your pressure transmitter, you get also this information, the FDI device package. On your DCS system, there should be the common file system, but associated to each type, you have to have such a device package. And the device package contains a couple of different things. The EDD, based on the EDDL, the language. The plugin, associated also with the FDT technology. The presentation afterwards, you will find more information about the FDT. And attachments. Details are listed below what this also can contain, for example, the device pages, visualization, graphics, task, role-based hierarchical menu system. But mostly it's easier as it sounds. Oh, forgot the last point. Of course, in an industrial automation environment, you have also the security aspect. So that the digitally signed elements are important, and that is the case for this FDI package, so that authentication and security for those files is given. The second part, what I said, the common host component, what is visible for you, that is independent of the component of the device type. So that is the software used in the host system, for example, a DCS system, and more or less invisible to the user It's interpreting and displaying the FDI device package in the system. Displaying means also functionalities like to print. The joint development effort for this FDI project was initiated by those consortia listed here. Randomly, there's no intention of order. The FDT Group, the Fieldbus Foundation, the HART Communication Foundation, PROFIBUS Profinet International, and the OPC Foundation. All those are involved in this effort to create the FDI technology, and all supported it and committed to integrate their technology, especially the communication technologies, in this technology. Benefits. What you get with this FDI technology compared to whatever you have had before. Investment protection. That's brochure number 1, what everybody would like to have. So system device investment protection over years of operation. What does it mean, saying over years? New device package requires no upgrade. So the EDDL portion of the FDI package is text-based, describes data and renders graphic much like an XML file. But XML file just provide a syntax, but here the EDDL is providing semantics. The second bullet is really important about the independence of this EDDL portion and the complete device package of Windows operating system, or whatever operating system you would like to have, so that you are compatible with all versions of Windows, not made for a specific version of Windows. There's no need to upgrade Windows, etc. when a new device type or version is integrated to the system. Based on this independence, the system is not rendered absolute by new FDI packages for new devices. And with that, FDI technology protects system investment. Here the device investment protection when I'm saying the Windows versions. If you have had a device what was based on a 32-bit operating system from Windows, then you got a wonderful new computer. Not all of those wonderful things what you have had attached to your old computer worked on the new one. Those effects, we don't want to have that. You will not see such an effect using FDI, the FDI package. This is independent of the Windows, .NET frame or whatever is used as an underlying system. I'm just talking about this device package, not the common host element. There are dependencies. So that you have system support for an existing device is not lost when a new Windows version or hotfix is installed. Unaffected by rapid obsolescence of the IT world. Probably in a private area you accept those things, but it is absolutely not acceptable in industrial automation arena. There you have to survive with installed systems over decades. No need to wait for a new FDI package before new Windows versions and language edition or language editions, etc. can be used on the system. New technology can be adopted faster. A system can operate without having to obtain updated FDI packages each time Windows is upgraded. Devices will not go obsolete since their FDI package does not go obsolete. The FDI technology protects device investments, so to pass the registration process, new versions of system will have to be compatible also with older versions of the FDI packages. So FDI packages are compatible in each case. Robustness, also important in industrial automation arena. So no driver installation, and with that no conflicts about your system environment. FDI packages are non-intrusive. Do not overwrite system files or make registry entries. Do not impact system robustness with that. Does not interfere with the system. FDI packages can be permitted onto the DCS itself. Device management can be integrated within the DCS operator workstation. The access diagnostic in 3 clicks or less without moving to a separate maintenance workstation. The NAMUR 107 status signals, for example, using predictive diagnostic becomes a natural part of daily operations and maintenance, as also in the ISA 108. That means the failure out of service limits, maintenance required, check functions. Those are important elements. Integrated device configuration, that means the EDDL portion of the FDI package can be loaded on the DCS engineering station. Loaded means not installed. Slight difference. System and device configuration from the same workstation, so easy to check ranges and other settings that they match, so that you can have all this also as a copy to the different systems. What you need, for example, a device management station and an operator station. Easy system administration, a single common technology instead of grappling with multiple technologies. That is what I mentioned, the SIP. It's more, but you can think as a little bit zipping of these elements. Easy to keep system up to date with new devices. New types and versions of devices come into the plant over its many years of operation. And that is really important within the industry side compared to commercial side where your gadgets are out of date after 3 years, latest 5 years. Here we are dealing with time frames of 10, 15, 20 and more years. The FDI package brings the system up to date with a new device. FDI packages for registered devices will be downloaded from the respective bus organization. That means the PROFIBUS site or Foundation fieldbus and so on. They provide those downloading that even you do not have to put in it manually by a data package within the box, only on just a link and you get it. Loading of FDI device packages is flexible. Both device pages and plug-in or just with the EDDL text-based device pages. EDDL portion of FDI packages is text-based, no operating system dependencies. Copied onto the system, not installed, it's not a program. With that, it does not require IT skills. It's easy to handle. Non-experts can integrate new device types and versions. Reboot of the computer is not required. So in the sense of sitting in a plane and a new device found, the Boeing 747 reboot, technicians need not to be given administrator access. That's also important for secure your system, that you can make less or cause less problems if you do not have the rights to override something. That helps. A common software import wizard as part of the system can help you to handle those FDI packages, and those are loaded the same way regardless of device manufacturer. That means multi-vendor don't care, even different communication systems don't care. They are working. HART, fieldbus Foundation, PROFIBUS, Profinet, whatever. FDI package for a new version of a device can be integrated without removing the FDI packages from prior versions of the device. Multiple versions of the device can coexist without a conflict. Also an important topic. The system can display a library of device types and versions. Each device type has its own FDI package. A single device can be integrated without loading other devices from the same manufacturer. The FDI package can include the GSD and CFF files. GSD file is a specific element for the PROFIBUS communication system, holding the communication-related information to establish the PROFIBUS communication. CFF file is something specific for a fieldbus foundation, so that you can also handle these within this let's say easy site zip file. The FDI package An FDI package can be loaded on one workstation and then automatically copied to another workstation in the system. That means saves system administration time. Host may provide services to automatically download the FDI files, and existing and future devices can easily be integrated into systems. The Easy Device database build. The FDI is a single common technology for all systems and devices instead of grappling, I said it before, with files and programs for multiple device integration technologies. The FDI package includes the codes for device manufacturer, device type and version. All this information are really important for your integration process. Control system and intelligent device management software automatically picks the correct FDI package for a device without manual binding. Plug and play, really, it is possible with that. And avoids a substantial amount of system configuration work. No license key, that means you do not have to provide a coin for each of those package. That means the FDI package for a particular device is part of your device type, reduces the cost and logistics of utilizing devices. The plugin can be licensed or may be licensed. There's only one FDI package for a device type. There is no need for tie-up to another FDI package to get full functionality. Makes it possible to take full advantages of all devices. This safe print, export and reconcile, etc. are provided entirely by the system, not by each individual FDI package. That's the common part. Therefore available for all devices, not just for some. Fast and low cost for device manufacturer. That means to develop your FDI package. Even you can then go to the www.EDDL.org, and there you will find a lot of useful information to develop such a EDD, and later on also on the FDI's website how to package this FDI package. I would like to hand over to Stephen that he dives in some more topics and also will provide you more insights.
Thank you, Ludwig. Good afternoon. My name is Stephen Mitschke. I am with the Fieldbus Foundation. Fieldbus Foundation is what we call a standards development organization. We develop standards primarily in the process industry. In this case, we develop the Foundation Fieldbus Network Communication Profile. My job there is Director of Products and Services, and I deal with managing specification working groups, volunteers that come together to help write the specifications, providing tools, again, primarily focused to both those people who are creating field devices and the necessary auxiliary items, along with systems as well, conformance testing, training, again, all specific to Foundation technology. I have been involved with device integration technology for, frankly, the last 10 or so years. Well, actually 16 years with the Fieldbus Foundation, but it was about 10 years ago that the Fieldbus Foundation, the PROFIBUS and Profinet organization, the HART Communication Foundation, got together to develop common extensions to what we call EDDL, Electronic Device Description Language. And this is nothing more than that, as Ludwig said, it's those drivers that come along with your field device, so that in the end, when you plug your device in the network, you don't have to sit there and map registers to values and all that stuff. You've got to get this sort of plug and play, just like you put your USB stick in and hopefully it comes up and says, here's your files, grab them off. The same sort of concept to your field device, where you connect your field bus to the network, or your HART device to the network. You load it up onto maybe your handheld tool or your PC-based application. Hopefully your drivers are SNOT. If not, you install your DD files, and then you have access to all those wonderful features that the device suppliers have integrated. So, and now we're talking about FDI because. What's happened over time is we had sort of this EDDL camp being formed, and we had this FDT technology being formed, which are really sort of two diverging, somewhat competing, somewhat complementary technologies. And obviously it's causing just a hassle amongst the different suppliers and users, because in the end you see double investment. People spending twice as much money on really trying to do the same thing. And so FDI is this work here where we try to take the best of both worlds and create a single device integration technology using some of those features of EDDL and FDT technology to a single integration package. So that in the end, as an end user, you need one thing, that FDI package that, as Ludwig said, hopefully comes on your Christmas tree. We want to make this easier for end users to utilize this technology. And so to do that, we of course write specifications, we develop tools and so on. But even then, a lot of people, they have, multiple systems in plants, right? You got a system that maybe from Emerson and ABB or Rockwell, because they've built over different times and so on, and you have to deal with the concept of getting everybody sort of trained up on these systems, and then you're doing device integration, and you might have the same exact device, right, that you might be using on one system or another system, and you really want to have that same experience of interacting with that device, whether you're doing simple things like a calibration procedure or configuration. And so here's where EDDL is kind of that key enabler, because it provides sort of the hints to systems on how to do sort of those different lifecycle activities. So for the device setup, being able to provide the basic menu structures to walk users through that, context-sensitive view. So at the same time, if it comes to a maintenance activity, or maybe you have a failure alert on that device, and now you need an expert to go out there and look at the device and see what's going on. The EDDL, all it's doing is it's basically describing those bits and bytes that come over that wire and help that visualize it on the screen. And the nice thing about FDI is we've gone beyond just simple protocols. We're doing this across communication networks. And so you see, 420 HART, PROFIBUS, PROFINET, and Foundation fieldbus. So in the end, from a device integration perspective, yes, the devices may have certain features, but how you actually interact with those devices, how you do those diagnostics, is actually relatively consistent. And this starts making it much easier for end users to kind of pit the best of both worlds. Because a lot of plants now don't just have a single communication network. Different networks have their pluses and strengths and weaknesses and so on. Sometimes it's driven by supplier, sometimes it's driven by user, sometimes it's driven by product availability. So you want to integrate all this stuff in a nice common way. So common software in some respects, associated with the FDI package and so on, you're going to really make that easier. Again, the idea for end users, you can choose the systems, you can choose your devices, but your integration is going to be common. So some of the key features that we've built into the FDI is sort of this wizard concept, and this is nothing more. You've probably seen this when maybe you've installed some applications on your PC, and it pops up a button that says do this, next, and so on. So we take that concept and we apply that to device integration. So within the FDI package, again, in the guts in there are these things called methods. And the methods are these little procedures that run for typical tasks. Set up and calibrate, to either set up the device, to do certain complex procedures and so on. But it helps guide, in this case, perhaps the instrument technician through that specific function. So these features are all sort of generically described in that EDD portion of that system manual. And the nice thing again about this is whether you're running that wizard on, say, host system A or host system B, or maybe it's not a PC base, it's a laptop, you'll have a similar experience because they're all being referenced from that basic EDD package. Now there are a lot of other strengths that we have to consider and sort of other sort of process requirements. Audit trails are very important because in the end you want to know who did what changes and all that stuff. Yeah, the nice thing about the EDD is in the end it's the system, it's your control system or your asset management system that really is taking control of actually configuring the device, using the hints that the EDDL provides for doing some of that stuff. And so therefore all the rules associated with audit management and permissions and stuff just are right at the system level, not programmed explicitly from an FDI package. Because believe it or not, device guys are really good about devices, but they don't know a lot about systems. And so you got to sort of do the right separation of responsibilities. The device guys are experts in their systems. They know how their devices. They know how those devices work. They know how to get those devices operating. They know how to tell you when that device has got something wrong. But they're not experts at engineering plants and dealing with user scenarios and all that stuff. That's really a system function. And so good level of separation there. Now so some of the key enablers to make this all work, I talked about it, are these sort of hints that are provided in this DD package. And so when you're doing some of this integration, when a device supplier is writing his EDD as part of his FDI package, he's going to say, all right, let's pull this display and let's put some text up there. Let's put a button, and let's put a chart up there that maybe shows a trend of the process variable, because maybe it'll help during this particular diagnostic related functions. The nice thing about these sort of controls with regards to the charts and graphs, or maybe it's a gauge chart or so on, that ultimately these are executed by the system function, not the device package. The device package, it's literally about 7 lines of DDL code. You can put that chart on the screen. That's real easy for a device supplier to pop that up on the screen. But on the system side, obviously it does the background work to take the process variable out and put that on a trend screen, for example, or a graph or a waveform, or maybe you're visualizing a valve signature that you might want to compare from a previous stored valve signature to see if you see any degradation in the quality of the equipment, for example. So the nice thing about EDDL is that control is managed by the system level. So that if you take a DD from one device manufacturer and display it, and then you have a different device manufacturer's product, maybe it's another valve or pressure transmitter, and you pop that screen up there, that same Windows control is going to look exactly the same. And so it really provides a much more unified integration of all these different things. You don't have to learn each individual driver packages for these particular devices. The consistency really makes it easier from a training aspect, because the way you interact with one device vendor's product is going to have that same look and feel as interacting with another device vendor's product. So we said, same things like help buttons and help text, and how you reconcile things, print, and all those functions. Irrespective of device, they're going to have that similar look and feel. It's going to make it much easier from a training perspective, and also just interacting and finding those things. Because Ludwig mentioned before, you don't want to sit there and have to go back to the book, right? No one likes to look at manuals anymore. And so we do our best to automate this on the various different device packages and make it easy for somebody, so that somebody who maybe doesn't have the strongest skills yet can sit down at a PC, interact with the device, and see something. And whether it's a temperature, pressure, or valve positioner from companies A, B, and C, it's going to interact and it's going to feel like you're working with a common set of products, irrespective of who built those particular products and irrespective of all that communication network that product might sit on. So whether you're interacting with a HART device, PROFIBUS device, Foundation fieldbus device, now I hope you're interacting with Foundation fieldbus because that's who I work for, but nevertheless, while you're working with all of them, it doesn't matter, because they're all going to have that same experience in working with those particular products. I mentioned a little before about context-specific use in developing the FDI specification, enhancing some of the EDDL components. We recognize that there needs to be some sort of common entry points, so that in the end there's consistency amongst the particular packages. And so each one of these device packages has a common entry point for doing device setup. So whether you're dealing with vendor A's device or vendor B, or whether it's a pressure, temperature, there's a known device setup page where you can go and do all your basic configuration of that instrument. There's a diagnostic page. So now, after you've set up and you've commissioned the device and you're operating it, and then there's a maintenance activity you maybe need to check to make sure it's in calibration, for example, there's a common device diagnostics root menu. Again, and the nice thing is some of this stuff is consistent amongst different device profiles, but also there's flexibility so that if a device vendor needs to add additional features specific as information, he has that extensibility. And ultimately, it kind of all integrates seamlessly within the particular system, whether it's, again, one system or the not other. Beyond that, we mentioned, powerful graphics. I mentioned before charts and graphs. From a device developer side, this is fairly easy for him to include within the package. It's a few lines of codes. Out comes this chart and graph, again, to visualize something. So instead of looking at tables and stuff, you can see valve signatures and appropriate graphical functions, for example. And certainly it's suitable for all aspects of the life cycle in the plant. So whether it's during the device setup, where you'll be using the core EDDL for device setup as well, but during other aspects of the phase, FDI does provide some advanced functionality through plugins, additional plugins. We call these plugins user interface plugins. They're DTM-like in some respects. This is the area that we sort of borrow some of that technology from the FDT group. But the nice thing about the FDT technology is it gave the device supplier full access. He could do anything. I mean, it literally is a device. It's a Windows application. And that powerful part about FDT is that if you're writing a real Windows application, you've got full system control. You got all kinds of advanced mathematics and functions, and well beyond what EDDL could provide. But the consequence of that is that you're really based on a Windows platform, and so all the headaches that Ludwig mentioned before about lifecycle updates and the fact that your typical Windows lifecycle is about 10 years or so, and after that, if you're not updating or you're keeping up with the latest system patches, all of a sudden that system-specific software can be tied really tightly to that driver. FDI sort of took a different approach. They said, EDDL is the core part of doing this device integration aspects. But when you need something advanced and the device requires something advanced, you can build a more of an app, I'm going to say. Not so much a full monolithic application, but a small little app to do that specific function. And the nice thing about FDI is that it sort of pops up seamlessly with your EDD-based menu. So from an end-user perspective, you don't really notice any difference at all. But the power comes in with that sort of separation between something that's a sort of a more generic text-based approach of EDDL and the Windows-based approach. Because in the end, if you want to do something powerful, like a very advanced diagnostics, or maybe you have a guided wave radar and you want to draw the tank, with some dots and real complex UI, or maybe you have a little function block programming tool where you want to do some drag, and more than what you can do with DD, you need a sort of app. You can do that with the FDI technology. The nice thing about that, again, is it's sort of scalable from a development perspective. So the devices that don't need that functionality, they don't need to spend that. It's going to keep the price of the devices down. But those devices that want that advanced functionality, they can provide that. So now when we create all this wonderful technology, in the end, if we don't really have a robust testing and registration program, the possibilities of interoperability issues rise dramatically. This is an area that we have a lot of experience in, as we've been doing now device testing now since about 13 years from the Fieldbus Foundation, and it's not unique to us. The HART Communication Foundation has a testing program, and the PROFIBUS and Profinet, they have their own sort of testing program as well. So we got this new technology, FDI, and we need a way to test that. Now, previously, the three foundations, the HART, Fieldbus, I'm in the middle, and the PROFIBUS organization, we had developed independent testing programs, and that costs money. You got to build tools, you got to test tools, you got to validate tools, make sure it all works. And it's amazing if we're all membership organizations down there, and if you look at the membership, there's a lot of common people they make HART devices, they make Fieldbus devices, they make PROFIBUS devices. They say, well, you know what? We're developing this new FDI technology. Maybe we could work closely together and build some nice tools to make it easier for us to build a common way for doing testing registration. I mean, even in the end, a HART device is a HART device, a PROFIBUS, Foundation Fieldbus device, Foundation Fieldbus device. But FDI is sort of a common element. And so here we had an opportunity amongst the different organizations to spend some common resources to get together and develop some common tools to help us. So that then I can take that same exact tool we built in common, I can use as part of my registration program. HART Foundation can do it. They might have some HART-specific tests. I'll have some Foundation Fieldbus-specific tests and PROFIBUS similarly. But in the end, we're still keeping to a basic fundamental concept of similar testing coverage across all protocols. By having consistency there, we'll be able to build something better that individually we could have done ourselves. But not only we got to focus on the devices side, because if you don't do testing on the system side, you don't complete the loop. Because the devices can interoperate all they want, but in the end, if your systems don't have the functionality that your device presents, you got an interoperability issue. You don't get access to all the functions and features that device supplier spent all his blood, sweat, and tears providing for that. So while we have certainly device registration processes, we're also working on host registration processes. And this is all essential to make sure that when that device supplier builds that one thing, that one file. Let me say this. So if you've had experience with DD files, they have cryptic names. 0101.ffo, 0101. FMS or FM8 or so on. They're horrible names, I'll be honest with you. Somebody invented them 15 years ago because they thought computers could find it easily. And that's true. 20 years ago, a computer could identify, build up a string, and find a file name. That's not very useful for end users. We don't think in 010101.cffs. Horrible. The FDI said, you know what, we should probably make this file name useful and not have to deal with a bunch of small ancillary files. Plus, you got all the certification files, the product manuals, because maybe sometimes you do got to go to that manual. Boy, wouldn't it be nice if you could have it right there, all in one nice single file with a good name on it? That's a nice feature that FDI is going to provide to simplify on that. But you got all these wonderful features in this package. You know, if they're not represented by the system, are they really there? Of course not. So we need to have a robust testing for the host system as well to really ensure that all those function and features that the device supplier provides is representing that feature, and to make sure that the experience that you get using one host system is going to be similar to the other host system. Because again, it all deals with buying into a technology and getting common look and feel to make it easier for you to integrate these devices across the multiple systems using a common technology that is FDI. So from a migration standpoint, FDI systems don't exist today. This is all kind of new stuff. In fact, Thursday, there's going to be a nice press release. Ludwig mentioned before this group called NAMUR. It's a German end-user group focusing on chemicals and pharmaceuticals and so on. They've been real active end users. They like to tell us standards development organizations, here's what we want you to do. But they got an annual meeting every year. This, Thursday, the FDI Co-op, we're going to actually announce first public release of our specifications. This has been a milestone in the way. We started this project in 2007. It's been a while. It's been a little bumpy. I ain't gonna lie, there's a lot of politics in standards. If anybody done standards, a lot of politics. But the light is now at the tunnel, and we're now to the point where we have solid specs where companies can actually begin doing their development process for FDI. They can start putting FDI into their life cycle plans. And so those specifications are going to be released this Thursday. And part of that set of specifications was a migration path. So if you have an existing system that's sort of EDD based, or you have a system that's FDT based, there's a migration path so that that system can move forward and support FDI. And more importantly, all those existing DDs that you have, all those existing DTMs can also interoperate in those systems as well. Because again, what you have works, don't break it. But as you migrate, as you do system updates over time, you can incorporate FDI. It'll be a nice, seamless transfer. And ideally, no investment lost. So all systems sort of integrate to this common integration technique. And again, we're talking driver files here. We're not talking about device firmware. I can speak certainly from with authority on Foundation Fieldbus. There's not a single thing in FDI that requires any change in firmware to those existing devices. Now, certainly if I was building a device from scratch, I might think about some things to make it easier. But the nice thing is FDI can apply to every single device ever registered from the Fieldbus Foundation, back since 1998 when we did our first device. And that same goes true for HART and PROFIBUS. It was built on technology that you can use for existing devices in your plants. It'll be some new files. There's going to be some new system software to be able to take advantage of this technology to all the benefits, but you're not having to replace existing devices. It's new features that are going to make it easier to interact with those devices in your system. So, what did we learn today? Let's wrap it all up. So, FDI is this brand new device integration technology. Again, FDI, Field Device Integration, because we all love acronyms. We have to give something, TLAs, three-letter acronym. FDI is the new device integration technology. It's been a culmination of work amongst the Fieldbus Foundation, the HART Communication Foundation, the PROFIBUS, Profinet organization. But this is really one device integration technology, bringing together. So it really is a single standard that can apply to all those different communication networks out there. And the good thing, it's built on the stuff that you already have today. So it protects your investments. It's going to provide greater robustness. We were talking about version management, version soup earlier on. How many times when you buy a device and then you set up a plant, so you engineer it, and you say, all right, well, we're going to Rev 1 device. We do all the system engineering. And you go to SatFat. Now I go to the installation, and what shows up in the box? Rev 3 device. Well, that's not what I engineered to. FDI deals with that. that whole version management. What files got to go with which device? And what happens when I get new files? And do they replace, upgrade? All those lifecycle scenarios have been fully considered as part of FDI. Real robust lifecycle. And that ultimately is going to make it much more robust and much more easier for doing device integration. When you get a new file, a new FDI package for that device, through your management of change procedures, and you get them updated, it's not installing new software. It's not running, double click on it, here comes the button, says now let's run. It's literally just throw a file into a directory, system imports, you get a nice little catalog, easy copy deployment, as we call it, strategies for bringing it in. And again, no explicit license keys or anything. Again, FDI is really focused on providing all the functionalities without the extra costs. In the end, it's about putting everything you need about that device into one location. All the necessary files, and not just the files, pictures of the files, picture of the device, so that when you plug in the FDI package, and here comes a little menu, a picture of the device, you're interoperating with it. And by the way, here's all the catalogs that might go with that device. Here's a list of all the certifications that device has had. That's all nice in that package. Here's that PDF of that product manual. How many of you have tried to find a product manual for a specific instrument? Sometimes that's not easy to hunt down. It's in the package. And it's all securely bundled up with X509 certificates. That's just a fancy thing of saying that the device supplier can timestamp it. You can put a special file in there so that when that thing's consumed by the system, we know A, that vendor actually built it, and B, it wasn't changed. And that's all part of that security mechanism to make sure you're going to have robust and true implementation of the device package. Again, to make technology successful, we need tools. We need to make this as part of a registration. So working closely with the different foundations, we've already developing a common set of test tools. I mean, these exist today. Okay, they're in beta form, but they exist today. And there are a lot of people starting to use some of these tools, start developing and begin bringing this new technology in. So again, here's an opportunity where we're putting money together to actually develop common tools that are going to better and make it easier for end users to integrate this new FDI technology. And again, investment protection, whether you have chosen an EDD or was chosen for you an EDD-based solution or FDT solution, there's a path for you to this new technology. Specifications are coming out, will be announced this week. There's going to be some tools that are, elementary tools that are going to be made available to a sort of a closed beta initially, and for those that are device suppliers within the Fieldbus Foundation, we'll make those available later on, probably the first of the year, to begin using that. So that hopefully, towards the end of 2014, 2015, that's my best guess, we might start seeing real registered, tested FDI products. Now, you'll see a bunch of examples of these soon. I know if any of you make it up to the Hanover Fair in Hanover next year, there'll be some FDI demos. Fieldbus Foundation, we do trade roadshow demos, and we'll be incorporating FDI as well. So there'll be some good opportunities to see this technology work in person. Again, some good resources. The FDI cooperation, that's the group that we all got together to create. It's actually a temporary organization. It was there to kind of house all the intellectual property. But we have a nice website, FDI Cooperation, talks about that technology. EDDL.org, which is run by the ISA 104 group. Specifically, Jonas, the author, has done an outstanding job of keeping that up to date. So there's good resources, good white papers. And apparently this speech will be on that video, so you'll be able to watch this again. And then finally, my website, fieldbus.org. I guess I won't also leave out, HART Communication Foundation. PROFIBUS and PROFINET organizations certainly have good information about the technology and FDI in general. So with that said, I wish you everybody a pleasant remaining show. Thank you.